Hey everybody, it's Jay Henry. In this video, I'm going to set up the Terraform scripts that we're going to use to create infrastructure in AWS for the computer vision service that we created a couple of videos ago. In the last video, we hooked up our repository, a new repository for the infrastructure code to Circle CI. And you can see here kind of the history of us trying to get it to work and finally successfully creating a sequential build and deploy kind of workflow. In this video, we're going to actually fill out this deploy stage to do more than just echo out deploy. It's actually going to use Terraform to reach out to AWS and create a number of resources for us. It's going to create a VPC or a virtual private cloud. It's going to create at least one subnet within that VPC. It's going to create security groups that control the traffic that can come in and the traffic that can go out, or ingress and egress. We're going to create a service using ECS. It's Elastic Container Service, and Fargate. And Fargate is a flavor of ECS that is serverless. So in normal everyday ECS, you would start up a bunch of EC2 instances and assign them to a cluster, and then the cluster would handle provisioning different containers on different instances based on their available resources. Fargate abstracts that away from us, and obviously you lose a little bit of control anytime you gain an abstraction. But I think for what we're trying to do here, the loss of control is not really going to affect us. And so we're going to use, a serverless container cluster so that we don't have to manage all the EC2 instances. I will say before I get started, setting up infrastructure code, especially in a CI/CD pipeline, is error prone. At least for me, it takes a long time for me to get everything just right so that the builds all pass. And I'll give you a peek behind the curtain. If we look at the workflows, these are all the failures I had in between getting something working for our sequential flows. These are all the failures I had trying to test out the Terraform code that we're going to add today. So if it doesn't work the first time, don't get discouraged, and don't give up. It just takes a little bit of time to get it right. So with that, I think what I'll do is first start by taking a look at the AWS resources. I have another VPC here. We're going to create one in addition to this. If we look at EC2, we're going to create some new security groups in here. We're going to create probably a new load balancer here. It'll be an application load balancer. And then we will go over to ECS, and we will create a cluster here. We will create some different task definitions. These are from a previous project. And then we'll create repository, at least one repository here to hold our Docker images. So I think without any further ado, let me bring up our project and let's start adding some things to this that we're going to need. And first, let's lay out our directory structure. So this is all pertaining to infrastructure. So normally if I was putting this with a repository that had source code that was not infrastructure related, I would create like an infrastructure directory and then create these underneath there. But since this is all related to infrastructure, I'll just start here. So we're going to want definitions, env for the different environments. For this one, we're just going to create the stage environment code, but if you had, dev environments, stage environments, prod environments, you would want to have different configurations here for each of those. Let's see, we're going to need some scripts. There's some things that we're going to be doing repeatedly that we want to script out. And then I think we probably just need I like to put task definitions in their own, I like them hyphenated, like to put them in their own folder or own directory so that they're easy for me to find, because those are just big like JSON files that we just load in and do a find and replace on tags inside of them, and you'll see what that looks like in a second. So start with definitions. The first definition I'm going to create is CloudWatch. Actually, I should probably declare variables first. That makes sense. And these files are all going to have the TF extension or Terraform. And this first one is going to be the variables. And so these are the things that are going to change across environment. So we want to extract them out into variables so that we can, have things like different regions, different account numbers, different number of AZs, things like that. And after we do this initial setup, there will probably be some things that we later on pull out into variables, but these are the ones that I thought of just kind of off the bat. Let's see, vision prediction port, and this is going to be the port that our service is going to accept traffic through. I'm going to set a default. I just always use this port as a default. It comes from like way earlier in my career. I don't really remember why. I think it was actually an error code or something. Variable region, we're going to do the default is going to be US East 1. Depending on how you want to set up your infrastructure, you can set up the same infrastructure in different regions and use that to get to kind of multi-environments, but I think most infrastructure professionals would tell you to keep everything in the same region and use different accounts for different environments. And maybe I'll do a video on that at some point. Let's see, env, we're going to default this to stage because that's what we're creating right now. Variable account, I'm going to put my account number in here, and I'm probably going to blur this out in the video. I don't know why anybody would need it or want it. It seems like all it can do is open me up to attacks if I provide it, so I'll probably just blur this out. Let's try that. I think that's my actual account number, but whatever. AZ count. So when we set up our load balancer, we're going to want to make it available in multiple AZs for fault tolerance. I'll just do 2 for now. You could do more if you wanted to have it be more fault tolerant. An AZ being an availability zone within a region. So the region US East 1 may have, I don't know, 3 or 4 different availability zones, and we'll see more about that I think later. And then I'm going to, this one's a little strange, so I'm gonna create a variable for a task definition path, even though it's really in that's not how you spell that, definition. Even though it's not really a variable, it's kind of going to be static. When I actually hard-coded it into the module that we're going to create earlier, it just looked weird, so I extracted it out into a variable. And I guess technically you could have a different one of these per environment, but I think for our config files, it's going to be pretty static. Alright, so with our variables done, I think the next thing I want to do is CloudWatch. And I'm going to create a CloudWatch definition which will just set up a log group for us so that we can, in our service, write to standard out and have that pushed over to CloudWatch so that we have logging without having to do anything fancy. So, do log group. And I'm going to call it vision predictions. Yeah, we're going to have multiples of these at some point, and so I'd like to easily say, okay, I want to see the logs for the vision prediction service. And we're going to do a little bit of formatting here. And what this is going to do is allow us to change the name of the log based on the environment. So I'm going to put in something like this. This is very Python-y. Let's see, vision predictions. And then I will tell it that I want to use the env var that we set up before this. Is that not right? Maybe that's not right. Maybe that needs to go there. Maybe that looks better. Yeah, that looks better. Oh, I think I know what I did wrong. Maybe it's that instead of parentheses, and maybe that needs to be something like that. I think that looks better. And then we're going to tell it how many days to keep logs. So if you don't tell it to truncate your logs after a certain number of days, they'll just build up infinitely, and you'll end up, spending all your money on log files that you don't use. So I like to expire them for a stage or a dev environment after 3 days. For a prod environment, it'll usually be driven by business requirements. If you're in a highly regulated industry, your logs might need to stick around for much longer. Some people even have like 7 years worth of log retention for compliance, but I think for what we're doing here now, just keep them for 3 days. That should be enough. And so that'll take care of CloudWatch. I think the next thing we want to do is create the VPC. And the VPC is going to be pretty simple, but there is kind of a lot going on there. And if you haven't used VPCs before, VPCs are virtual private clouds. They're just isolation within AWS of your resources. So you can you can set up your own private network and then set up subnets within it and all the networky stuff that you can do in there to really secure your environment and route traffic the way you want and isolate things from each other. So first thing we got to do here is declare data for availability zones. And then we're going to say available. And this is a weird kind of data in that we're not going to specify where it comes from, but we are just going to point it to a subnet that we're going to set up, and it'll tell us based on the environment, the region, it'll tell us what subnets are available. So it's kind of weird. It doesn't make a lot of sense that we have to declare this, but we do. And then let's declare our actual VPC. I can't spell my own name. Code vision. Yep, that makes sense. We're going to give it a CIDR block that we want to use. And then 16, so that's just declaring the available IPs that we have. Enable DNS support, yes, we do want that. And then enable DNS host names, we want that as well. Real quick, like the entire scope of all of the networking and communication and security concepts and ideas that go into creating a virtual network in AWS are far beyond the scope of this video. This video is more the how do I get it up and running than the explain all the concepts to me. But I will leave some links in the description to give more background on a lot of these concepts that I am just basically skipping over at this point. Let's create a subnet. Let's see, AWS subnet public. Yeah, let's do that, and let's say count equals var.az count. And again, this was from our variables over here telling us how many availability zones we want to use. And this count is basically the rest of the scripts. It's going to iterate over that number. So ours is 2, so it's going to execute these scripts twice. Let's see, CIDR block equals CIDR subnet aws.vpc.jhenrycode vision. And so you'll see here we're actually, come on, J. Henry, learn how to spell your name. We're actually referencing the resource that we created here in here, which is a great feature of Terraform in that it's very declarative and you can later reference things that you have created before. And then let's go index. This 8 is just splitting this 16 in half. So I'm basically splitting this. Later on we'll create another subnet which will be private, and we'll use the rest of the IP addresses for that. But for now we're just going to make the public subnet. VP CID again is AWS VPC, and then that's actually an error right there. And then it's again J. Henry code vision, and we'll tell it to use the ID for the VPC ID, and then availability zone data.aws availability zones dot available dot names dot index. And this is actually what referencing this weird data declaration that doesn't have anything in it. If anybody knows like exactly how this works and can explain it to me, please let me know in the comments, because it just doesn't make a ton of sense to me. AWS, we're going to create an internet gateway so that we can actually flow traffic in and out of this VPC. I swear to God, I'm learning to spell my name. Do it until I get it right. Internet gateway. And then we'll just tell it the VPC to use. And then it's ID equals yes, VPC.jhenrycode vision.id. And that's all we have to do here. This will create a VPC for us and set up the internet gateway so that we can get traffic in and out of it, and it'll create a single subnet inside of it, which is the public subnet. And so now we're ready to declare some security settings. So let's go security.tf. And by the way, you could put all of these things in the one file if you wanted to. If you wanted to have a file that was like, here is my stage stuff, or here is my entire environment, and I just want to parameterize it, you can do that. What I found is that it makes sense for me to split these out into different modules, especially as they grow and change. It's easier for me to say, well, I need to change something in my VPC as opposed to, CloudWatch, and I don't have to hunt and peck through, code, hundreds of lines of Terraform scripts to find it. But if you feel more comfortable putting it in a single file, you can totally do that. All right, so let's create a security group here. Resource, AWS security group. Call this J. Henry code vision. I like to use the same names over and over again if I can. It makes it harder for me to make a mistake when I'm referencing other stuff, but it also tells me all this stuff belongs to the same thing. Again, we'll tell it the VPC ID, and even though it's not in the same file, all these files are going to get aggregated when we run them, so it'll have access to the VPC that we created. And .id, and then we're just going to, no, I don't want VPC ID, I really just want the ID. And then we're just going to declare the ingress, or the traffic that is allowed to come into this security group. Protocol is going to be equal to TCP. The from port is going to be 0. The to port is going to be 0. And CIDR blocks equals 0.0/0. All traffic from all sources can come into this security group. In a production environment, you would definitely want to lock this down more. You would want, to only allow certain ports in. You wouldn't want to have every port be open from every address, but this is not production grade, and I just want to set it up and make it as easy as possible to wire all this stuff together so that, we can learn how to do it. So the next thing I'll do is the load balancer. The load balancer is going to be one of the more involved pieces. And the load balancer we'll be creating is an application load balancer. And the difference between an application load balancer and like a network load balancer is that the application load balancer, if you're familiar at all with the OSI stack, it executes at the application level. And so basically you can do things like inspect your network traffic as it comes in and like look for things inside of your network traffic to do routing, which is what we're going to do. Whereas at the network layer, it can't look as deep into the data that's coming in. So it's just a fancy load balancer, I guess. So we'll create an ALB. We're going to use the same name for it as for everything else, and there are some places in this code where I'm using vision prediction as the name, and that's when it is very specific to what we're trying to do with that. Like this load balancer could be used for other services within this project. So code vision, we're going to say internal is equal to false. This will be an external load balancer. The load balancer type will be application. And I'll leave something in the description for the OSI stack. I'm not sure how many people still study that in school. I don't know, maybe it's still a fundamental thing. It used to be. Subnets, AWS subnet.public. This is the one that we created in our other file, and we're going to give it a wildcard and say use all of them. Security groups. And again, these are the security groups that we created previously. AWS security group. This should look familiar. ID, and this is obviously a list or an array. Idle timeout, 5 minutes. That should be good. It's not how you spell idle, but there we go. And so now we've got a application load balancer. So we're going to add something to it, which is a target group. ALB target group, and this target group is going to tell us, what kind of protocol it will accept and what it will do with the traffic that comes in over that protocol in specific cases. So, and this is where we'll get into more specific names because we're routing this traffic in a specific way. So, code vision. This is the HTTP listener. And I specify that it's the HTTP listener because if we wanted to add a SSL cert to this, and we do, and we will at some point, we would have a different listener for SSL traffic. And some people will not ever expose HTTP to the outside world, and I think that that's a good practice. I still like to have an HTTP listener that is maybe locked down to a specific security group or something so that we can do SSL termination at the load balancer and do HTTP traffic, which is just, faster between like API gateways and services, but we're not there yet. All right, so start using some of those variables that we declared. Vision, prediction, port, I think it was that 9001 value. The protocol will be HTTP. We'll tell it what VPC. We're in AWS VPC. .jhenry code vision .id, and then target type will be IP, Internet Protocol. And then we're going to tell it about a health check. So this is how we can monitor our services to make sure that they are up and running and that they have not unexpectedly failed. And we'll use that so that if they do fail for some reason, ECS will start up another task to replace it. And so it's, you have to have a health check to make sure that your services come up and stay up. So we'll say healthy threshold equals 3. Interval is the threshold is how many successful pings you need before it's considered healthy. We're going to ping it every 30 seconds. The protocol is going to be HTTP. The matcher is 200. That means what kind of status code you need to get back in HTTP 200 for it to be considered a successful ping. Timeout will be 3 seconds. And then we'll give it a path. And the path is going to be prediction version. And so our service is going to have an endpoint which it has a version file which will tell us, basically it's just going to output a static file, but that version file will be updated every time that we update the service. So it's a good way to check to make sure that your latest version has been deployed. And then unhealthy threshold, we're going to set it 2. So if it fails twice, we're going to say it's unhealthy. And I think that's all we need for that. I think now let's add a listener. AWS ALB listener. Yep. And this one, we'll use the generic name. We'll tell it what load balancer that we want to use here. So load balancer ARN is the AWS ALB J Henry code vision.id. We'll tell it the port again. And the port is going to be var.vision prediction port. So you can see how it's kind of good to have some of these things split out into variables so that you're not, you don't have magic numbers all over the place that if you want to make a change, you've got to change them everywhere. Let's see, protocol. Let's use that IntelliSense. And then default action. And the default action will be to forward traffic to the target group that we just declared. Group ARN AWS ALB target group .h. Oh, that's not that. Our target group is called J Henry code vision.id, and then the type will be forward. And that should do it for that. And then the last thing we're going to do is we're going to give it a rule. So because I don't need equals there, I don't think. Because this is an application load balancer, we can give it, code in essence that it can execute when it looks at network traffic that's coming in to make decisions about how to treat this traffic. So let's see, listener rule vision. And this one is going to be, more specific than our other naming conventions because you could have a different listener rule for each service, and you can prioritize them. And well, I'll just get into it, and it'll make sense in a second. Listener ARN, AWS ALB listener J Henry code vision .ARN. I think that's right. Yeah. And then we'll tell it priority. And priority is the priority that this rule is going to be evaluated in. So if you had 10 rules, you could number them 1 to 10, right? With 1 being the one that will be looked at first, 10 being looked at last. What I like to do is start at 100 and then go up by 100 for each one. If you ever programmed in old BASIC, their line numbers, you had to specify your line numbers, and you always left huge gaps between the next line number because you knew at some point you were going to have to go in and make a change. So I do kind of the same thing here. All right, so the action that we're going to take here is type equals forward. And then I think the target group on, right? And we're going to target the target group up above. So we'll say ALB target group dot J Henry code vision dot on. And then condition, and this is the part where it's interesting. This is, excuse me, this is the part where we're going to tell it what type of traffic to do this with. So we're going to give it a path pattern, and we're going to say, give it an array of path patterns, and we're just going to give it a single one. And what we're going to say is anything that starts with prediction, is this asterisk is a wildcard. Anything that starts with prediction is going to get forwarded to this target group because it recognizes this pattern, and then it'll stop executing. And I think that's it for the load balancer. So I think that's the majority of the stuff for our VPC. The next things that we need to create are around the cluster. And so the first thing we need to create is a repository, a Docker repository, and we're going to use ECR for that. So we'll say ecr.tf, and we're just going to create a repository, and we're going to tell it what type of thing we're going to be pushing up there and how long to keep the images. So we'll say resource AWS ECR repository, and we'll give it a name, code vision. And you know what, I actually think I want this to be a little bit, well, no, right now it's a single project. If we need to split out different images in the future, you know what, I'm going to go ahead and do that now. Vision predictions, yeah, because we're going to have different services, and each one should have its own repository. Name will be vision predictions. Good. And then we're going to give it a policy that'll say, hey, if this thing basically is not used in 14 days and it's untagged, just get rid of it. So AWS ECR, let's see, is there a policy? Repository policy. And we'll call this, yeah, vision predictions policy. Normally, I think it'll be the same for everything, but it doesn't hurt to have a separate one right now. We're going to tell it which repository, and the repository is AWS ECR repository .vision predictions .name. And I think that'll work. And then the policy equals a string that we're going to input, and then it's going to treat it like a file is basically what that is. So let's say rules, and we're going to give it an array of rules. We're really going to give it just one rule. The rule priority, I'm just going to have one. I'm not going to start at 100. I think that'll work. And then selection. And this is telling it what type of images to look at. So if our tag status is untagged, and some of this stuff will make more sense if you haven't worked with Docker before. I think in the next video we're going to actually create the Docker images and start building them and pushing them up to this repo. So some of this stuff might make more sense than if you're not familiar with Docker already. Let's see, count type equals since image pushed, and so if it is untagged and let's say count unit I think is days, right? This should be, yeah. Switching back and forth between these is sometimes a little chaotic. And then count number. Don't turn on caps lock. Get you every time. And so what this is going to say is find untagged images that have been in there for 14 days. And that's basically it. And then the action will be that we are going to expire it. Type expire. And that is our repository. And so the last thing that we're going to need to create is the cluster. And so ECS, Elastic Cluster Service, and we're going to create the cluster. So AWS ECS cluster, we'll give it a name. Now for the name, it can be very generic because we can have, and we'll have multiple services within it. So we can have a single cluster where we can group up the services. And I think that makes sense for this. And that's all it takes for the cluster. But let's create a template file. So this is actually data and template file. We'll call it vision predictions. And then we will tell it where the template is. And we haven't created it yet, but we will. File. And this is where I'm sorry, that's not necessary. And this is where I'm going to give it this long path. When I first set this up the first time, I actually hard-coded the task path here, and something about it I didn't like. And so I refactored it out. Let's see, account. Bar.account, that's going to be important. Actually, all of these are going to be important. Whoops. Tag, we're going to need a tag. A tag is going to be on what the Docker image is tagged as. And like I said, in the next video where we actually build the image and push it up to ECR, I'll explain how we use that tag and why it's important. Log region is going to be important, so we know where to get our CloudWatch logs and where to send them. App port is going to be what did I name that? Oh, vision prediction port. Good. Let's put that there. And then the host port. Now we could actually set these two different values. So and oftentimes we will, but this 9001, we could have the container communicate on that port, but have the host proxy information on a different port. For now, we don't need that kind of complexity, so I'm just going to set them both to be the same. And again, when we build the Docker image, you'll see how I do the, or how I guess everybody does, port mapping on a container when it's starting up, and this will make more sense then. And we're going to tell it what environment that we're in. And this might actually be a good time to create our task definition. I think we might as well. It's pretty simple. So let's call this, and what did we set this to? We haven't set that yet, so we can set it to anything. Let's actually give it a default here. No, I don't like that. I really don't like that. I'm not going to do that. That's just as good as hard coding it. Alright, so task definition, I'm going to say vision predictions .json .tpl or template. And this is going to be basically a JSON-like file. And so it's just going to have some stuff that we can replace and pass in environment variables, things like that. Let's see. entry point. We're not going to need this maybe ever. Definitely don't need it right now, but we may not need it ever because we can specify the entry point in the actual Docker file that we're going to use. Let's see, what else do I need? Environment. I don't think there's anything there. Essential. Yes, it is essential. So I will say true. And then we're going to pass it in an image. And this will be the Docker image that we're actually going to use to run this service. And so this is where you need to specify your account. And again, this is, you could hard code your account here if you're only ever going to use one AWS account. But if you are going to have a true dev stage and production environment, you're almost certainly going to want to have different accounts for stage and production. And so I think it's good to give yourself that flexibility here. And then we'll say what region we want it in. Amazon AWS. And then we're going to vision, predictions, and tag. Don't worry too much about those until we get to the Docker part. I think I need quotes here. I'm going to put quotes. I don't think it'll hurt. It might hurt if I don't. All right, and then log configuration. This is going to be important, and this is where we're gonna tell it to use CloudWatch log driver. There are other types of driver configs you could use here, like Datadog, or I think like FluentD. I'm not sure exactly what providers they have available. But I generally use CloudWatch, and then I have a sweeper integration pickup from CloudWatch and aggregate all my logs. Let's see. Option, we're going to say AWS logs group. That's not right. Let's do it like this, yeah. And we're going to say env, and we kind of did this vision predictions, kind of did this earlier in our CloudWatch, so it's going to be very similar, just a different type of interpolation there. AWS logs region, and we're going to say, I think we've already got, do we have a variable for log region? It doesn't look like we do. Why is that giving me an error right there? Alright, I'll get to that in a second. Let's just use the regular region. We'll assume that they're going to be in the same region. We'll just say region. I don't know why we would want to send the logs to a different region than where the service is executing, but I'm sure there's a case to be made. AWS logs stream prefix, and this will just make it easier to find when we have multiple different types of projects running in the same region. I think that'll work. Let's see, what else do we need? We need a name, and I think the name will be vision predictions, port mappings, and again, not going to get too deep into this until we get to the Docker part. So let's say container port app port, and those are numbers, so I shouldn't have to surround them with quotes. Host port will be host port. And again, it'll be the same for now, but it could change, and we want to give ourselves that flexibility. And then the protocol is TCP, and I think that's it. I don't think we need anything more than that. And so we can go back here, and now that we've got this, we can declare our task definition. So AWS ECS task definition and then the task definition is going to be vision predictions. And then the family will be code vision execution role arn. Now this is a var.ecs role arn. Did I declare that? I think I did. I did not, so I'm probably going to want to declare that. But maybe now isn't the right time. So this role arn is going to be a role that you have set up in your AWS environment that has the permissions that it needs to create task definitions in ECS on your behalf. A network mode is AWS VPC. Oh, here's the fun part. Requires compatibility. Compatibilities. And we're just going to tell it to use Fargate. And again, I'll link some information about Fargate in the description. But it is a... what did I not... I feel like I'm missing some variables here because I need to declare variables for all of the stuff in here, like CPU and memory and things like that, and I probably had better go ahead and declare all that stuff. Yeah, because I'm definitely going to want to parameterize this for different environments, so let's just do that now. And then I'm going to give it the default for my environment. I will probably blur this out in the video because I don't know why anybody would need this. Probably just opens me up to a vector of attacks. Let's see, variable, and then we're going to need CPU and memory settings. So this is going to be how much CPU and how much memory we allocate to each of these services, which, you know, you definitely are going to want them to be bigger and beefier in production and maybe stage than you do in, you know, a dev environment. So we'll just give them some defaults for now, but give ourselves the ability to change them later if we need, you know, more resources. Predictions, memory. Let's see. I think that'll be it for now. If we need to add any more, we will. Oh, and let's give this a default as well, and that can be 512. So let's go back over here. So now we've got variables we can use for this. This makes more sense. Let's cheat here, and then let's see. Let's say that we're going to set memory, and that again will come from here. Just cheat a little bit, and then container definitions equals data dot template file dot vision predictions dot rendered. And so this is going to read in this template file. It's going to render an output, and that's what we're going to use here for our container definition. And that'll create our task definition. And so now we need to create the service that will run this task. So AWS ECS service. Again, vision predictions will be the name of the service. Vision predictions. I'm not sure why I need to specify the name after I already named it, but whatever. Let's tell it what cluster we want it in, and we will say that the cluster is jhenry code vision, and then tell it ID, obviously. And let's see, what is the task definition here? The task definition is going to be the one we just specified, so it'll be vision predictions, and then it's an ARN that it wants here. And then how many of these do we want? And this might, should I declare a variable for this? I'm not going to. It seems like overkill. So you might want to scale these out horizontally, and you might want to run multiples of these in a different environment, but for now, I'm just going to leave it as one. Let's tell it we want it to be a Fargate launch, and then we'll give it a network config. And the network configuration, we're going to tell it what security groups to use. Groups, and we're just going to tell it the one, AWS security group jhenry code vision.id. Subnets, we're going to tell it the subnets we want, AWS subnet.public, and wildcard to tell it we want all the subnets, and then assign, surprised that's not there, assign public IP to true. Let's see, load balancer, I'm going to tell it what target group to use. Let's see, target group ARN, yeah, AWS ALB target group dot vision. What did I name that? What did I name our target group? Let's go back to our load balancer, to our target group. I named it HTTP. So if that's our target group, why is it? Yeah, I thought I remembered doing something wacky there. We want the target group to be HTTP. Alright, I feel better about that now. Target group HTTP ARN. Let's see, container name. Container name equals vision predictions, and container port equals var dot, I don't want to write that whole thing over again, vision prediction port. So I think I mentioned at the beginning of the video, this is a long video because there's a lot here. It's just very verbose syntax. Although when you think about it, it's much less much less effort to do this than to go into AWS and manually create all these things. Listener, it depends on our listener, right? So what did we name our listener? We'll go back to load balancer or jhenry code vision. Okay. Henry code vision. bvision. No. And that is it for ECS. So I think what I'm going to do now is I'm going to pause the video, and I am certain that I have made some kind of syntax error in here somewhere. So I'm going to pause the video, go fix any syntax errors that I have, and this code will all be checked in, and I'll leave a link to the repository in the description. So if I make any changes that are subtle or even major ones, you'll see it in the checked in code. So I will be right back. So I just realized I'm not going to be able to test this yet because I haven't created the environment that we want to, the parameterized file that we're going to use to set all these variables. So let's do that first, and then I'll take a break and test it. So let's, in environment, let's create one environment, which is stage. The reason we're going to need to get in there is because when we use Terraform, it's expecting a directory path to tell us where to load everything up. So in here, I'm going to create a single file, stage.tf. This file is not going to have a lot in it. It's basically going to set up a backend, set some credentials, and then it's going to tell us to load up everything that we just wrote and run it. So say Terraform. We're going to say, what is the back end? And the backend for this, I've set up a bucket in S3 on AWS. It's a good idea to stick your, so Terraform creates like a state file where it tracks all these things and manages them, and it needs to be a file that can be accessed from a lot of different places. And so I like to stick them in AWS so that not only can I access the state locally, but when I push them up to my build server, the build server can also access the state. And we'll see what that looks like in just a minute. So I'm going to say that I have a bucket that it needs to look in, and that bucket is jhenry code vision. We have a key, and I'm going to tell it that it's stage inf for infrastructure tf state, and this is going to be the file it actually modifies to keep track of all this stuff. And then I'm going to tell it that it's in US East 1. And that's it for that. And then I'm going to tell it provider. So Terraform will work with AWS, it'll work with Azure, it'll work with OpenStack, I think. It'll work with just about any provider. So you have to tell it that you want to use AWS, and then you have to give it some information. So I'm going to say shared credentials file. This is particular to my machine. And it's a good idea to keep your credentials separated from everything else so you don't accidentally check them in and give people access to your AWS account. Default region equals US East 1. And then we're going to set up our single module, and our module is going to be jhenry code vision. And we're going to tell it a source, and this is why we needed to tell it. This is why we needed to set this up this way. Let's see. Oh, and here's a fun thing. We're going to actually, this is where I'm going to parameterize this, and I still am not sure if this is the right way to do this, but this is the way I'm going to do it for now. So I think the path to this is task definitions, vision predictions dot JSON.tpl. I don't know. I still feel funny about that, but whatever. So now that we have this, I'm going to actually pause the video and go and work out any syntax errors that I have. And again, like if they're major, I might unpause the video and call them out. If they're minor, like missing commas or something, you'll see it in the code when you take a look at the repository. So I'll be right back. Hang on. Okay, so there were some syntax errors, things that were misspelled, some things that were, replaced by autocomplete. There were actually a missing variable for tag, but I think I got everything working. And if I pull over, you can see what I did is I executed. Where's that command? Is it all the way? Yeah. So basically, I executed. Is it all the way up here? No, I can't be that far up. Anyway, there's a command. There it is. Terraform apply, and it went and checked my environment, saw that it needed to create all this stuff, asked me if I was sure that I wanted to do this. I said yes. And I'll show you how to auto do it when we hook it up to Circle CI, but you can see it takes some time to create some of this stuff. But if we pull up our task definitions, no, it's not ready yet. You see it has created a cluster. It hasn't created the service yet. But if we go and look at EC2, it's probably created our load balancer by now. Yeah, so our load balancer is there, our listeners are there. We can view and edit the rules, which are the ones that we set up. So it's not quite done. Oh, and we had an error with the policy on the test definition. So I'll take care of that, and then I will rerun all this stuff and kind of show you the output. So give me just a second. Okay. So I fixed the problem with the policy. It was just had some formatting issues in the policy text itself. Seems to have all worked now. So if we go back and look at ECS, I'm hoping that we will have a task definition, and we do, and that's good. That's good. Cluster. We should have. I'm sorry. That was a Kubernetes cluster. So in our we should have a single service. That's good. It probably won't have any tasks running, right? Because we haven't actually pushed anything up to our repository. Even though the repository is there, I don't think I have any images in there. So I'm going to do one more thing in this video, which is, when you create all this stuff in AWS, it costs money to have it up and running, although this particular infrastructure is very cheap. But should you want to get rid of it very quickly, Terraform destroy, you can actually tear down everything you just built very easily. If you can spell things correctly, which I cannot. And what this will do is it'll do the reverse of apply. It'll take a look at all of your stuff, and it'll say, hey, I'm gonna tear all this stuff down. And so while you're testing, while you're playing with this stuff, it's a great command to kind of wipe out everything you've done and start fresh. Just don't run it on production. Although if you did run it on production, like the whole idea behind infrastructure as code is that you can get it back, but still, don't run it on production. And this will take a couple of minutes, which is fine. And then all of that stuff will be gone. And in the next video, I think what I'm going to do is actually hook this process up to Circle CI so that every time we check into the master branch of this repo, it updates our infrastructure. And I think as part of that same video, we'll go ahead and update the Vision code base to actually use Docker to build an image and push it up to ECR and then redeploy the task. So if any of this was useful or helpful, please like and subscribe below. If I did anything wrong, if you think there's a better way to do any of this stuff, mention it in the comments, because I'd like to learn some stuff. Otherwise, thank you for watching, and I will see you next time.